Hello guys, today we'll be learning about embedded system. So let's start. An embedded system is a computer designed for specific tasks. So embedded system is designed only for the purpose of specific tasks. It doesn't do multiple tasks like computer. It is small, low cost and consumes less power. Examples like mobile phone, blood pressure monitors, digital multimeters, weather monitoring device. So main components is the microprocessor in embedded system. So main component is microprocessor in the embedded system. What is does it executes instruction sequence by sequence, and we need and memory is also a component of the embedded system which stores programs and data. So programs or data are stored in memory. Peripheral interfaces. So peripheral interfaces are is a medium in which we connect processor to external devices. Input output devices are those devices like keyboard, monitor, etc. Input device is something like keyboard and output device is like monitor. And bus transfers data between components. So uh, if data wants to be transferred from one side to another or any component or path, that is done through bus. Think it like a bus, like real life example like bus which travels from one place to another. Same thing here in embedded system, bus transfers data from one component to another component. So program are usually stored in ROM and it is not stored in RAM, read-only memory. That is, program is are usually stored in read-only memory, which retains data even when power is off. So even when the power goes off, the ROM will store the data or the program. So what is microcontroller? Microprocessor, memory and peripheral on a single chip is known as microcontroller. Embedded system is equal to microcontroller application specific hardware or software. If we say like microprocessor, so microprocessor inside the microcontroller. So microprocessor is inside the microcontroller and microcontroller is inside the embedded system. So these embedded system and microcontroller microprocessor are embedded inside a system. Let's go to the next slide. So examples on embedded system. Communication application radios like telephones, cellular phones, answering machines, fax machine, wireless routers, consumer electronics like washing machines, clock and watches, games and toys, remote controls, audio or video device, automotive system, braking system, electronic ignition, door locks, power windows and seats, collision avoidance system. These are some examples of embedded system. There is more over here, that is commercial application, ATM machines, barcode readers, elevator controllers, medical application like cancer treatment equipment, dialysis machine, blood pressure monitors, ECG machine, industrial applications like automation, oil refineries, food processing plants, paper and board mills, military application, missile guidance system, GPS system, surveillance system. So now we will come to like what are the design parameters of embedded system. So some of the important design parameters are power consumption. So power consumption should be low to increase the battery life and efficiency. So power if it is consumed low, the battery life will increase and the efficiency of the battery will increase. And next point is speed of execution. System should perform tasks quickly. So speed of execution means like how the computer perform tasks quickly. System size and weight should be compact and lightweight. System size should be compact and lightweight. So system size should be small, like compact and lightweight. It should not be heavy. Performance accuracy must perform any assigned task correctly and reliably. Means that accuracy should be more. So, goal of embedded system design. So, we can say that achieve the best trade-off between cost and performance. Parameters for selecting microcontrollers. Processing rate and processor size. This determines how fast the controller can execute instruction. So, these are the parameters on selecting microcontroller. First is processing rate and processor size, input output interface support, memory size, RAM for temporary data storage, and ROM for permanent program storage. So, memory, ROM and RAM. So, what is memory? Memory is something that stores data and program instructions. Each memory location has unique address, which means that, like, there is one, suppose there is a one memory where data is stored, so each data has particular address. Read and write operation, so these are very important operation. Data also, I missed one point. Data is stored at these addresses. As I said, data is stored in these addresses, like one particular memory location has one particular address. So read and write operation. What is write operation? So data moves from processor to memory. So write operation means when data moves from processor to memory. Read operation means data moves from memory to processor. Please remember this. Data moves from processor to memory in write operation, and in read operation data moves from memory to processor. Types of memory. Read only memory, mainly used for storing program permanently. That is, it is used for storing program permanently. So we are not getting chance to change the program. That means, like, for say example, Windows, which is a program which is stored in ROM. Normal allows read operations only. As I said, read operation means data means removes from memory to processor. So it allows only read operation. There is no write operation over here. Data remains even when power is off. Yeah. So it's called non-volatile. So data remains when even the power goes off. Non-volatile basically means that itself when power is off, data remains. Writing to ROM requires special hardware. So if you want to write in ROM, that requires a special kind of hardware. Let's go to RAM, that is random access memory. Here it supports both read and write operation, used for temporary data storage during execution. As I said, ROM is used to store permanent programs, but in RAM, only data is stored only temporary. So data is lost when power is off. This is called as volatile memory. Random access. Both ROM and RAM allow data to be accessed directly using their addresses. So this is a figure of memory address and memory content. So as you can see, this is the memory content which is in binary form, that is 1 or 0, and these are the addresses allocated. So this is the memory address 1, 2, and it can goes on to 414243444142, something like that. So, so as we know, ROM, read only memory, allows read operations. Here I will be using read operations. Please note it here that read operation data moves from memory to processor, and write operation data moves from processor to memory. So during read operation, which means data moves from memory to processor during normal use, only allows read operation during normal use. It is non-volatile, meaning data is retained even when the power is off. These are discussed in earlier slides. Used to store program code, firmware, and boot programs. Types of ROM. So basically, there are four types of ROM. One is PROM, EPROM, one is EEPROM, flash memory. So PROM means programmable ROM. So it can be programmed only once. You cannot program like multiple times. We can program only once. Contents cannot be changed after programming. So this is a permanent program where contents cannot be changed. So if you want to replace the program, chip must be replaced for modification. So EPROM, which is erasable program ROM, can be erased and reprogrammed, sorry. So EPROM is nothing but can be erased and reprogrammed. It uses ultraviolet light for erasing, must be removed from the circuit before reprogramming. Entire chip must be erased at once. So electrical erasable PROM, erased and programmed electrically. So due to electrical, we can erase and program the EEPROM, can be reprogrammed without removing the chip. Here the advantage is it can be programmed without removing the chip, but in EEPROM we should the chip must be erased entirely. So supports byte-wise and page-wise operations, faster and more convenient than EEPROM. As I said, EEPROM is better than EEPROM. Flash memory. Flash memory is a type of EEPROM, reads and writes data in large blocks. Faster and cheaper than EEPROM for large storage. Widely used in USB drives, SSD, memory cards, and embedded system. Has a limited number of arrays and write cycles. So let's go to random access memory. So we know RAM does both read and write operations, and it is volatile. Volatile means data is lost when power is goes off, suitable for temporary and frequent changing data. So this RAM is suitable for temporary and frequent changing of data, faster than ROM. So there are two types of RAM. One is DRAM and one is SRAM. So DRAM means full form is dynamic RAM, and SRAM full form is static RAM. So DRAM, each cell consists of capacitor and transistor. So the cell contains of capacitor and transistor. So required periodic refreshing because charge leaks. Since capacitor leakages the charge, we need periodic refreshing, that is reprogramming, and it contains higher memory density, meaning that there is more memory cells, slower due to refresh cycle. So it is slow due to refresh cycle, commonly used as main system memory. And in SRAM, static RAM uses flip-flops to store data. So here we use flip-flop to store data. No refresh operation required. As DRAM requires refresh operation, here SRAM does not require refresh operation, and it is faster than dynamic RAM, but it is more expensive and occupies more chip area, commonly used in cache memory. So if we see the difference between SRAM and DRAM, So SRAM speed is faster, DRAM speed is slower, and refresh required. SRAM no, and DRAM yes. Cost, SRAM is high and DRAM is low. Density, SRAM is low, DRAM is high. So what is application of SRAM? Application of SRAM is cache memory and application of DRAM is main memory. Now we will learn about an aligned and unaligned access. So memory access starts at an address suitable for the data size. So we know that byte refers to 8 bit. That is, sorry, 1 byte refers to 8 bit. Any address is aligned. So half word is 2 byte, that is 16 bit. So half word must be divisible by 2. Sorry, the address must be divisible by 2, and word 32 byte, that 32 bit, which is 4 byte, address must be divisible by 4. So these are all aligned access. So byte, any address is aligned. So byte doesn't have problem of aligning any address if it is even or something like that. But in half word, address must be divisible by 2. So if address is divisible by 2, it is known as half word. And if address is divisible by 4, it is known as word, which is 32 bit. So what is we learned about aligned access. Now we'll learn about unaligned access. Memory access starts at an unsuitable address. So address is like odd here. Half word access from an odd address. Word access from an address not divisible by 4. So if unaligned basically means like half word like 16 bit contains address of odd, and word contains address which is not divisible by 4. So if we see the example, half word which is 16 bit, address 100 is aligned. As we said, half word address is divisible by 2. So if we see address 100, is it divisible by 2? Yes, which is 25. So it is aligned. Now if we look at address 101, if we see if it is divisible by 2, it is not divisible by 2, so it is unaligned. Since it's OR 101, it is basically unaligned. Now if we talk about word which is 32 bit, 4 bytes, address 100 aligned. Since 100 is divisible by 4, address 102 unaligned. Since 102 is not divisible by 4. Sorry, and half word it's divisible by 2. So address 100 means it is divisible by 2 into 50. It is divisible by 2, which gives like quotient as 50. And as I said, word is divisible by 4, that is unaligned. Even if it's not divisible by 4, it's unaligned. So why alignment matters? So what is the use of this alignment? Aligned access are faster. So if memory addresses are aligned, so access to that aligned is faster. But for unaligned access, it requires multiple memory operation. So to access any memory location which is unaligned, it needs multiple memory operation. Some processor may generate exception for unaligned access. So some processor will not work for unaligned access. So there is exception here. Thank you.